Welcome back to Visual Image Interpretation. Today we are going to learn about how to interpret the image, any image, that is whether it may be aerial image or a remote sensing image. So what exactly your image interpretation mean? It's nothing but an act of examining images to identify the objects and judge their significance. That is, take any photograph, either it may be aerial photograph or any remote sensing satellite image. You need to identify what all objects are present on that. So when you get this information, you can use it for many problem solving cases. That is, or in other words, what we can say is you can go for extracting information, or it is an information extraction process from the images. So the interpreter who is going to interpret what objects are present on the photograph has to be a specialist who's been trained in the study of photography of imagery. So no, it also involves a considerable amount of subjective judgment, and it is highly dependent on the capability of mind to generalize. So if you see this simple image, if you see, an image is a pictorial representation of an object or a scene. Now these images can be either analog or digital. Now if you see analog, aerial photographs are generally analog, while your satellite data is in digital form. Now what exactly is this digital image? Now this digital image, it is made up of many small square or rectangular areas which are called as pixels, or in other words we can say each pixel represents a pictorial, it is nothing but a pictorial representation of an object. If you see this, this is your aerial image of South Mumbai city. And if you see this, this is a satellite image of South Mumbai city. If you see the difference between both of them, satellite image is more clear rather than an aerial image. Okay, so we will just go with the visual image interpretation on a digital image or a hard copy. So we have 9 important elements of interpretation, with the help of these elements we go for interpreting an image. Now these 9 image elements are being proposed by Charles, and they have been classified either qualitatively or quantitative. That is, a few of the image elements, they are being used for qualitative interpretation of the image, and the others, they are being used for measurements. That is a quantitative interpretation of elements. You can, with the help of your shadow, you can find the height. So these are your 9 image interpretation elements. So we'll just go in detail with the 9 image interpretation elements. So the first one is a shape. Now when you have an object, you can go for identifying the outline of it. Seeing the shape of that outline shape or outline of the object, you can say what it is. That means you can go for identifying what it is, either a flowing water body or a lake, that is, or a stagnant water body, like that. This is just an example. Then the second one is your size. So relative to one another, when you go for comparing the sizes of the objects, you can go for saying what it is. The next one is your tone, that is brightness or color. Depending upon the brightness or hue or color of the feature, you can go for identifying what object it is. For example, see, you have your water body which is very deep, that is, which is very deep. Then you can say, you can see the dark color or the bright color. Whereas when you have a surface water that is very plain, little amount of the water, then it shows a different color. So that is what is your brightness. Next one is your sight. Sight is if you know the area, that is the location of that image, then automatically you can go for identifying plenty of objects on the image. That is your sight. Coming to the texture, that is the surface, whether it is smooth or coarse, you can go for identifying the image. Next one is your shadow. That is, if the object's shadow can be used to determine height. Next important element is your association. That is, association is nothing but features that are normally found near the object. So depending upon the objects that are present near to our target, you can go for analyzing and then interpret it. The last one is your pattern. So depending upon the pattern, also see, for example, if you take the help of your pattern is, if you see a forest area wherein the trees are randomly placed, and compare it with your agricultural land. So when you see the reflection of these two scenes on an image, you can clearly distinguish both of them. You might be feeling both are green in color, both are plants. And how do we go for distinguishing? No, depending upon the pattern, that is, your agriculture farmlands are in the form of bits, that is rectangular or square bits, and uniformly they are being placed. Whereas your forest, it is randomly having all the trees. So the difference can be easily found out by checking with the pattern of the objects. Okay, is it clear? So we'll just go with few examples. Depending upon the shape, how do they look? Okay, so if you see the airport, it looks like this: a bare land, a beach, bridge. If you see, you can even also find the culverts. Commercial land and industrial land, you can see how packed they are. And you compare these two with the residential area, it has a difference. Then you have this river, which is a flowing water body, and a pond, which is a stagnant water body. The difference you can find out: one is a line feature and the other one is a polygon feature. Then you can find out that viaduct. Very easily you can identify them. Then if you see the stadium, open stadium, you can easily find out depending upon the shape of it and the structure of it. Then parking. All these things, that is, with the help of shape, structure, size, pattern, texture, etc. With the help of all these 9 elements, you can go for very well interpreting an image. So if you see the methods of image interpretation, we have either manual procedures or computer assisted procedures. So if you find the basic principle of image interpretation, the basic principle is nothing but it depends upon the interpretation. It depends upon the nature of the object, that is the physical nature of the object. Not only that, the object's reflective property. So depending upon the type of the reflection of the object, your object can be distinguished from other objects. And if you see the factors governing interpretability, see, in general, if you see, an image interpretation can be done very well by an expert and by a normal person differently. So what is that is governing this interpretability? The first and the foremost thing is training and experience. Who is interpreting the image? Second one is nature of the object or the phenomenon. Nature of the object. What does that type of object that is being screened? So what is that? The quality of the photographs. High resolution photographs, it's very, very easy to interpret. And it also depends upon the type of equipment, that is what type of camera you're using for taking the photos, and also the method of interpretation. Now, when you want to confirm whatever you have interpreted, that is whether it is correct or not, then you need some manuals, some standards to compare yours. You need to understand them. You need to have them. And also, if you have a prior knowledge of that area, you can very well interpret the objects on that area. Okay, now coming to the techniques of the visual image interpretation. When you go with the techniques of the visual image interpretation, it has 3 important facts. First one is the measurement of the images of the objects, that is the scale of the image. Second thing is identification of the objects, and whatever information you have extracted, you should use this for some application, that is for some problem solving. And it also depends upon accuracy of the results, scalings, etc. All these things are the factors that are governing them. Then coming to the activities that are taking place under your image interpretation, we have detection. That is the first step in detecting the objects in an image. Second one is your recognition, which is nothing but identification of the objects. Third one is analysis. Now that object, whatever object you have identified or detected on the image, is nothing but a tree, a building. So that analysis has to be done. And unnecessary things, you get lots of things other than your target, you're going to detect them. Then after finding out that, after distinguishing, after identification, then what you do is you just go with the classification. For example, we have a vegetation, bigger vegetation, wherein older plants will be there, fresh plants will be there, herbs will be there, shrubs will be there, big trees will be there. So this all things, depending upon their reflection and on an image, we can just go for classifying them also. That is what is your activities under your image interpretation. See, there are a few examples here. The sensors in photographic image interpretation. This is the left one is a black and white panchromatic image. The right side one is a false color image. See, the black and white panchromatic image, You have a stadium. The shape of the stadium itself says that what object it is. And the right side in the false color photography, you can see a bigger monument, its shadow, and through which you can go for determining even the height of that monument also. And this is a black and white aerial photo. If you see this image, the upper right corner, there's a hydrofoil ship which is emitting radiation. Depending upon that emission, you can find out that there is some ship here. So the other big ship is a tanker delivering the fresh water to the island. See, you can find out the difference between a color that is a normal one and a false color photography. See, color photography, it uses a 3-layer film with each layer sensitive to different ranges of light. For a normal color, what we use is they are sensitive to blue, green, and red light, what we see with our own eyes. That is what is your normal. That is, the trees appear green. Whereas in a false color photography, the trees which appear green in a normal one, they appear red in color. That's a difference. Okay. So here actually what happens is, in a false color photograph, the targets with high near infrared reflectance, they appear red. And those with the high red reflectance, they appear green. And those with the high green reflectance, they appear blue, thus giving us a false presentation of the objects. So that is what is your false photography. So now we'll go with an image interpretation for multispectral images. Basically, these 9 elements are being categorized under different heads. That is what is your resolution, stereoscopic ability, individual band interpretation, and temporal data. So this is one example, which is a Landsat image, Boston, and these are your circular features, indicate sprinkler irrigation systems. This is a data. This is an image from IRS, that is Indian Remote Sensing Satellite. And this is one of the Goan city false multispectral image. This is a mountain and the rocky terrain. See here, if you see the pattern and texture, that is the surface of the earth, can be easily clearly seen here and interpreted very well. So that mountains and rocky terrain is reflecting differently when compared to your normal soil or barren land. So these image characteristics are distinguished into spectral characteristics, spatial characteristics, stereo, and associated features. These are nothing but the 9 elements have been classified under these things. So this is your tone. Depending upon the gray tone, they have gone for things. A will represent your farm, B is your river, etc. So you can see here, this is being a classification of the vegetation. A, which is very, very dark in color, because they are green and fresh vegetation. And B, if you see, the reflection is different, the pattern is different. There are small plants. And C, old plants. D is your bushes. So depending upon this texture and pattern, you can go for classifying the vegetation. So this will show you a hazardous. The right side, extreme right side, is an area of a water body. The left one is the flooded water body. See the pattern? Full color and panchromatic. You can easily find out this, the thin lines. That is nothing but the pattern of your plant. Spatial characteristics, shape, size, shadow, pattern, and texture. We have already done this. See, this is a very beautiful example for size and shape. The size and shape of it itself can give you an interpretation, can give you an idea about interpreting what it is exactly. So this is nothing but a pentagon. See this here, pyramids. Pyramids, you can also go for taking the help of size, shape, pattern, and shadow. Shadow can give you the height determination also. This is association, Hoover Dam. See the shadow of the Washington Monument? Very well. It is beautifully, you can see in that image, and you can directly find out to determine the height of it. The shadow. See the shadow of the animal on the image? This is your pattern and texture. See, this is your desert area. Desert, the soil, that is your sand, how it is. That pattern exactly you can see on an image. See, if you have some knowledge in interpretation, you can easily go for identifying. Bamboos, bamboo plantation. This is Uttarakhand floods. And our own Hyderabad city's Hussain Sagar Lake, which is heart-shaped, you can very clearly see in your Google map. This is your Musi River in 2001, and this is your Musi River in 2016. Now we don't need to say it as Musi River. We can just simply say it as Musi Canal. Yeah. Now, this is just a small homework for you. If you can see, uh, depending upon the shape, size, structure, everything, all those things, you can identify plentiful of things in this image. You can go with the stadiums, like extreme left sides, and right side also one small stadium is there. Viaduct you can see, flowing water body you can see, the roads, highways, everything is visible. So you can go for easily interpreting them. So with this, we'll be ending this session. If you have any questions, please put on me in the inbox. I'm going to clear it. Meet you in the next class.